So we are the Snow King Beekeepers Association. I'm Eli Ocheltree. I'm presenting on the annual conference of the Washington State Beekeepers Association, of which we are a member club here in this Snohomish-King County area. I'm just going to cover highlights, and it's just my perception, my view of them. Just me, a journeyman beekeeper in Snohomish County. There's going to be a PDF that accompanies this, and these are the talks that are on YouTube that you can access. And this is kind of nice because it gives you the length. Some of them are longer. If you're familiar, if you're comfortable running things at a high speed setting, I don't think you should run me at high speed, but there are really slow talkers that you can change the speed on the settings and run them and cut this time down. But just so you're prepared for how much. Some of these are excellent presentations, and they were worth every minute of the time watching them. There was a hobbyist track, a science track. I'm going to leave this in the video that we're recording now. I'm also going to have a PDF available that you can get to when you join our group discussion page on Facebook. We're going to skip over some of the talks. There's one on the Asian giant hornet, the murder hornet. Okay, we're all tired of that, right? And there's lots of information out there. The Washington State Department of Agriculture, that's easy to access. There was more talk about Varroa, and we are so tired of the D word. I know we are. We have to talk about it. We have to face up. We are grown-ups, I think most of us, and we have to face Varroa as a challenge. A lot of the question and answer sessions I'm not going to talk about, and there are presenters that you frequently hear. Randy Oliver is a very popular presenter. Dewey Caron is a professor emeritus now at the Oregon State University. And Ramesh Sagili is very available too. He's at the Oregon State University working in the bee labs and department there. Randy Oliver, I have to put this in, and I hope this isn't going to get me in trouble. He is what I call a presenter who's an easy listening experience. He's well known as a presenter, presents on beekeeping, and he's well liked by hobbyists. However, I never recommend any of his videos, almost never, because he throws out ideas. He just tosses them out. He does random research citations. If you go to the website that he has, scientificbeekeeping.com, it's chaotic. He'll propose an idea, he'll reverse it, he'll discard it, he'll go back to it, and if you try to follow his website and even his beekeeping career, beekeepers tend to get confused. He is a very interesting person to talk to. Seriously, I would sit down and talk to him anytime. But when you are, I keep admitting people, sorry. Nope. When you just get too confused. People hear him say something once and they don't understand that he just made a suggestion. I think he would even probably admit that if you talk to him. But he confuses people, so I don't recommend him for beginning. If you get to intermediate, you'll probably be more comfortable listening to him. There is something for everybody, though, left in the highlights that I want to cover. A lot of talk about nutrition, including those fungal extracts. Just as they're good for people's immune systems, there is a lot of interest in those fungi and the extracts from them helping out bee immune systems. Queens, quite a bit of talk about queens. Beginners aren't as interested in queens, but by the time you're into your second or third year, you're thinking, how hard could it be to raise queens? Well, there's a couple of really good talks on that. There's, for the botanist, the gardener, the ecologist, there's all kinds of talks on forage and habitat and pesticides. And actually, they all sort of come in and link together. The chemistry, particularly there's a lot of talk in nutrition about sterols, polyphenols. It was brought back memories since I have a degree in biochemistry. And it was really interesting to hear what people are talking about, that I just did it in a dry chemistry book. Much more interesting the way the presenters present it. There's graphs and research data if you're into that. And if you want to kind of leap over it, You know, you're in control of the clicker, right? Especially on YouTube videos. There's the easy listening type things. There's some beautiful scenery. I love looking at pictures of bee forage and bees, right? And there's always that concern, can we reduce the chemical treatments for Varroa? Everybody wants to do that. And there is some very practical hive management and overwintering success presentations. Two presenters are new to me, Jennifer Short and Zac Lamas. And I thought they were both really good and worth following to see if they do more presentations. The whole conference started out with an introduction and then an overview of where the WSU, which hosts the Agricultural Extension Service for the state. They are the Agricultural Extension Service University. And they are really into bee breeding and genetics, artificial insemination. They do queen raising, queen rearing, and queen inseminating workshops out there on the east side of the mountains. Steve Sheppard is one of the professors very involved in that. And Sue Cobey is actually internationally known for her work with collecting semen from around the world, especially with carniolans and colder weather bees. She's one of the few times that I would really listen to people who are saying they're interested in getting a different strain of bee that does better in this climate. I don't know about locally bred, but the carniolans, the Caucasians and such were meant for a colder region than the Italifornians that we keep buying in our nukes and packages. And I call them the Italifornians because they have nice production and docility of the Italians, and they raise brood. They love the big families, but they come from California up to this damp, cold western Washington area. Queens. Sue talks on the queens. That's what that is her specialty. But Zac Lamas also talks on requeening, a good talk. And a lot of it's on hive management too. You can't raise queens or requeen and risk your most valuable player, sort of like in chess, I guess. Your most valuable player, or in football, your VIP, MVP, most valuable player. Okay, same thing. Your management has to be good, and they talk about management in that relationship. Honeybee management in general. Jennifer Short, I had never heard give an entire presentation. I was very impressed. She's up at Camano Island. Get her information, and if you're interested, I definitely will listen to more presentations by her. Zac Lamas, if he does more too. Dewey Caron, he's professor emeritus, and he's a nice guy, and what he says is important. It's just he didn't have that zing. Sorry, but you get evaluated a little bit on whether you got the zing. Nutrition. There was a lot on nutrition and forage. And not just, they tell us, take the little pollinator packet and go out and sprinkle it. And if you get the plants to come up, your honeybees never go near them. Have you ever noticed that? Anybody tried that? Okay. Pollinators, especially native pollinators, love a huge variety. Honeybees select. They're picky in a lot of ways. They like diversity, but quite often they will go right past that carefully planted seed crop that you put in that you thought they'd be interested in, because over how many yards over, there's something they really, really like. Higher nectar, certain type of pollen they like. So there was a whole talk that I'm just going to refer to quickly. Tim Hyatt is the man who is the sort of a lobbyist for Washington State Beekeepers Association. He's responsible for that gross negligence, willful misconduct clause that I mentioned that limits our liability just having bees. So people can't just sue us randomly and frivolously. And his talk was on the recommendations that are now before the Washington State Legislature. And they're very detailed and they're very interesting. If you want people to plant pollinator habitat, he goes into a lot of ways that you could use roadsides. You could say every public landscape project has to have 25% something for pollinators. There's so many ways to work it in. And he's interesting. I'll talk about him later. He made it much more interesting than you would have thought it was. Andony methylopolis, Oregon Pollinator Protection Plan, they've been working on theirs, and theirs are slightly different for Oregon State. But he has a lot of talk about exact plants. So his is very, very that way. Tim Hyatt's is very how he got everybody to talk to everybody, how you get pesticide applicators to sit down and not get into fights with the beekeepers who believe their bees are getting poisoned, or the native pollinators who really don't want them around. And getting these people to talk was really wonderful, his explanation of it. Ramesh Sagili, he made a quick mention of supplemental pollen forage for specialty crop growers, partly because he works where Andony methylopolis works. And there was an interesting slide of bloom times in Jennifer Short's presentation. Fungi, that is really big now in bee talks and bee research. Jennifer Hahn did a great explanation of how she did it, how she did her experiment. That'll be fun to cover. And Nicholas Naeger, he got a lot into the chemistry and how to feed the fungal extracts and how they're working on that. Forage kept coming up again and again. I think I repeated myself there. Okay. And all of this seemed to overlap. I was surprised at how much overlap there was. Although the question answer sessions are kind of confusing, and there were a couple, like I said, you get to hear these people talk all the time. You will frequently hear Randy Oliver talk, for example. He's often the keynote speaker too. But it was interesting. Honeybees and native pollinators don't actually overlap in some ways that much on the forage, which was one of the things that kept coming up. So I sort of tried to show that with a little Venn diagram there. But when you're getting into how does all this, anything about forage benefit the commercial beekeepers and such, it's very important to remember, what do we tell you to look for to know whether or not the queen's laying and whether there's brood? What's the thing that we always drill home in beginner class? You look to see if the bees are bringing in pollen. And it's not that all bees need protein throughout their lives, but they need a lot of pollen when they're raising brood and when they're gearing up in the spring and when they're trying to maintain that going into the nectar flow, and then they might back off. That's one sign of dearth, right? But if you don't see that pollen going in, if that pollen isn't out there available, they can't raise the maximum number of brood that they would like to. And oddly enough, when you put hives out for pollination, if they haven't had enough pollen, and if the pollen isn't nutritional enough, they're not raising brood. If they're not raising brood, they won't forage for pollen. You actually, and that is why in the pollination contracts, when a grower pays for so much per hive, in the contract is how many frames of brood are in there and a laying queen. So all of it comes full circle around. It's all related. Research benefits, it often seems like commercial people are getting the lion's share. The native bees, those people, they have a different type of research they're really looking for, like getting a baseline ID of how many native species we've got in Western Washington. Do we have 400, 600 or more species of native bees? Actually, we don't have a good baseline study. Great citizen science project if anyone's looking to set one up. The small scale beekeeper, well, we can benefit some from commercial, although there's at least one study in here I go, what does this have to do with us? And it probably doesn't have much, because we do approach things differently. And just as we say in the beekeeping classes on the how-to, you don't have to do everything a commercial beekeeper does when you're a hobbyist. And if you're in between, you may have to decide what you want to do. I think everyone's in. Good. So, one of the first speakers in the two-day conference was Steve Sheppard, and he was talking about Washington State University's breeding program, which they've been working on for years. In the upper left-hand corner, this is Sue Cobey, who has 2 talks in this conference, and she's really interesting. What she's doing there is collecting semen And generally, actually, she's quite happy to show you and has videos of how to collect semen from drones, you know. And it's very interesting. She really loves her subject. Cryogenic storage, of course, means the liquid nitrogen. Semen can be stored for a long period of time, and other cells too, but semen is especially easy. We have the 1922 quarantine on adult bees being brought into the United States unless you have special permits and approvals from the U.S. Department of Agriculture, and I don't know how many other pieces of paper and red tape. So bringing something like semen in is a lot easier, and it does control for a lot of pathogens, not all, but it does cut down what you might be bringing in addition to the genetic material that you're looking for. So I think it's Steve Sheppard that does this talk, and he goes through some of the species. So if you've been hearing about the Carniolans, the Caucasians, and the Italians, and you're wondering, did they come from different places? Yes. And he goes through that. He goes through a roadmap. Fascinating. If that's your interest, and there's something for everybody in this conference. Now jumping to Sue Cobey, I just showed you a picture of her. Here she is harvesting, and this is a drone, and here she is harvesting the semen by squeezing a certain way, and and she's showing you the bulb there of that contains the actual semen. And then she talks on about how she is bringing in semen from like the Carniolans, and even I think she's bringing in some Italian too. Caucasian, I'm not sure if she's bringing that in or not. In recent years, we've had Caucasian and Russian bee genetics being brought in. I assume through the semen, since we still have the basic ban on the import of adult bees. Fascinating to listen to. Don't have time to do, I mean, she's got years, I don't know how many years of work on this. The full name of her talk was Successfully Managing Various Queen Issues. Not just requeening, but how to introduce a queen, how to bank a queen, how to find a virgin, what to do about laying workers, how to get quality control. In the spring, we are somewhat laughed at in this area because we'll pay $40, $45 for any queen we can get. But the reason why is that our weather can delay any queen rearing attempts in much of Western Washington. So they have to be brought in, and there's costs involved in that. And this last year was bad, especially rainy spring. So she talks about how the conditions, the hive management and everything is going to influence that queen's reproductive capacity and her performance later. There is a big problem with queens not lasting. There are people who don't even believe in letting them live beyond 2 years. I've actually heard of commercial beekeepers who said just requeen every year. Solves a lot of problems. You always have a young queen. But for the hobbyist, I'm not sure. It would be nice to go back to really good conditions, get the right size queen, full ovarial development or spermatheca where she stores the sperm. That organ develops. She has the capacity to store that semen and keep it alive for however many years she is a laying queen, because she only mates once. It's an unusual phenomenon, even in animals, not unknown though. And her pheromones, directing the hive, holding everything together by her contribution to the pheromones. She talks about how do you know if you're queenless or not. That's always a neat topic in beginning beekeeping classes. I don't have time to really cover it, but I stuck it here, and I'll see what I can do on the PDF. Maybe I can just do the slides in PDF format. Here's another one of hers. She doesn't skip the drones. They often don't get discussed enough, but they are important. There's thousands of them per hive, though, compared to the few queens that a hive might produce in a year naturally, although you can raise queens and get more. I'm going to move on with requeening, even like her presentations were both wonderful, to Zac Lamas, who is the only person I think who doesn't have his PhD yet that presents at this conference. But he has a really great way he presents his information. For example, he starts out saying, why is beekeeping so hard to master? Why does it have such a high failure rate and a high frustration rate? And people sometimes don't come take their beginning beekeeper class until their second or third year of the bees failing. And some come the first year and they still fail because you still miss something. Why is it so hard? And he says, it's not like milking a cow. And he uses milking a cow and he goes and he explains this. And I felt so much better when he explained this. And every beginning beekeeper should feel good when you listen to how he explains it. He says the problem is beekeeping, you don't repeat a task until maybe a whole year later. And then the conditions changed. If you're going to make a split, okay, and you're going to do it in the spring, but the spring, the weather's different. And that's a whole year since maybe the last time you did a split to prevent a swarm. He says, if you look at it like milking cows, you go out and you milk that cow twice a day and you get it right, or else you have lots of repetition and there's a reward or a consequence immediately. You know if you did it right or wrong. Think about mite treatments. We don't know if our mite treatments are really working or not unless we do a lot of monitoring. And even then, sometimes it doesn't seem to have enough effect. But milking that cow, you get milk out or you don't get milk out. And the milking has to be done or she'll get udder infections, I'm sure. Then he goes on with his different methods of how to introduce a queen. And a lot of this still has to do with management and such. How to pick one up. He actually spends some time showing you how to pick one up and talking about it. This is something we don't have enough videos out there, I don't think, on YouTube of good practical things like that. He shows you an easy method to set up a nuke. Using the queen excluder that I always say in beginner class, don't use a queen excluder the first year for excluding a queen, except when you're doing certain techniques. And he does this technique where he gets all the frames that he wants to put in the nuke. The 5 frames that you see here, he puts them on top of a queen excluder, on top of all the bees in the lower box. Queen can't come up, but if he has brood in these 5 frames, if you remember what brood pheromone does, if there's open brood in those 5 frames, it's like they are screaming, take care of me, feed me, warm me, how could you ever leave me? And so all you've got to do is put those 5 frames there and then cover it up. You can do this in the evening, he said, come back the next morning and you will have it filled with bees, nurse bees, the young bees that you want. And you didn't do a lot of messy shaking. And anybody who's ever done a split, you're going to fall in love with his way to do it. I like his way to do it. He worked with Mike Palmer, and it could be part of why he has such great techniques. Mike Palmer's definitely worth a look. Okay, Jennifer Short, she was another surprise. She used to be a dairy farmer. She's a veterinarian. She went into it. She's working with bees, and the title doesn't make any sense. It's working with bees, simple ways to make what you need. That's not at all what it's about. It's about tips. And if you have gone through your first year of keeping bees, what she says makes so much sense. And you're really gonna enjoy listening to her. If you're looking for a few tips, I think almost anybody could pick up something. She does warn you that if you get into queen rearing, which she does, you've got to be a record keeper. Keep the records, keep the records. There's the queen calendars you might recognize, especially we quickly go over that in beginner. Then she talks about your yearly plan. I thought this was really neat. She just put this up. This is your monthly task list. Yes, it's not perfect. It will have to adjust with the weather and everything else and what you're doing. But it was interesting that she just put it up and talked about the planning. And then, did you do it this year? Or are you going to change what you do next year? Then she even had a forage chart, and this is hard. I've tried to make one up. This one looked pretty good, and for her area. I'm surprised at how much English ivy we have. But she put some things in here that are pretty much familiar to everyone. Well worth a look. I like this presentation. Okay, now I'm going to jump to fungi. And we've all experienced seeing our bees messing with the mud pile or the ickiest, yuckiest thing around. I mean, cow manure. I put clean water out and they won't drink it. It's just like my dogs and chickens and everything else. They don't like clean water. And we've always said, well, it's kind of micronutrients. Well, fungi might be the solution. A study of fungi might actually get us to what it is and what they're feeling that they don't have in their forage, especially when their forage starts to get limited. We feed them the sugar syrup, which isn't the best, but it gets them going in the spring. They're good pollen. So we're in this area in Western Washington, we always kind of say, okay, I'm feeding them sugar syrup, but they're getting good pollen, natural pollen, even if I put a little extra sub in there. Their resilience is partly going to be based on nutrition. The immune system relies on good nutrition. You have a nutritional deficiency, you're more likely to get infected by a pathogen. If there's a general decline in honeybee health, look no further, is what Nicholas Naeger is saying. And then he had this really neat thing about, we always talk about human nutrition. It's not that different for bees. There's a few differences. So here it is, your eat a rainbow to get your phenols, your polyphenols. And they contribute to the flavor of honey and the colors and everything that makes it special. Good for us. But bees, to make that honey and get those phenols and such, are actually eating a fair amount of fungi. One way they're eating it is in bee bread. And we talk about, they put a little nectar in, they pack the bee bread, the pollen that they bring in, they bring the pollen pellets in, put them in the cell, and I think they kind of bash it with their head and pack it down, put a little nectar in, and it sort of ferments, we say. But this isn't just yeast, which is a fungus. It is a number of them, and he goes into some of them and how that changes some of the nutrients in there. But that's important because it turns out there's at least one critical, I didn't put it right here, there's at least one critical nutrient that they don't make. And the polyphenols, I don't think they can make it. They get that, but they need sterols. They cannot make sterols, which is really interesting. We can make them. It's one of the things that we can do. So he goes into this, and then he talks about how the antioxidants, the phenolic antioxidants found in honey, are important for bee health. Honey is better than sugar. We're not surprised at that. But fungi are actually doing the chemical part of the process to break down wood, lignin, and they are providing that breakdown the compounds, phenolic antacids and such, antioxidants and such. I must have it in the next talk, the explanation of sterols, that they don't make their own sterols. They must get those from plant and fungi sources. Don't forget, when we're talking about nutrition, that most bees aren't fortunate enough to get good nutrition naturally, especially throughout the whole year. Even in this area where the pollen is good, we do, and the blackberry flow comes through with the nectar and maybe the knotweed, and there's some others in there, fireweed if you're in that right area, a number of plants. But getting to late summer, we tend to have the late July, August dearth. The wildfires, they made a difference. The autumn can be very dry. If your knotweed is not good enough, that your bees will have troubles. So and then if you put holding yards for commercial pollinators with all the bees packed together with nothing natural out there, or the pollination crop, which is a monoculture, you put that into the mix, you have poor nutrition automatically. And the sugar and corn syrup that we feed them, they just aren't honey. Now, I jumped here. I think I'm going to pick up fungi in a second later. Sorry about that. I was putting these together. The Zac Lamas, who did such a good job explaining requeening and beekeeping isn't like milking a cow, that same guy has a really interesting last half of this talk, which is labeled Winter Prep. And it is a really good talk on Winter Prep Begins MidSummer. You've heard it, I know, I'm preaching to the choir for many of you. You have to start making the plan in July and August and seeing how your bees are doing to prepare them to make it through our, unfortunately, mild but rather long winter. I keep talking about the bees cannibalizing in my classes, and I was fascinated that he finally put little charts up and talked about it. When the larvae is infected or damaged chilled brood. You know, they say it's the beekeeper that does it. I think sometimes it's that sudden frost, late frost that happens in April. Catch the hive when they can't cover all the brood that well at night and keep it at that 93 degrees that it really likes. But also when larvae are injured and sick because perhaps it's a virus or it's the Varroa, the worker bees, the nurse bees, have to take them out. But unfortunately, they've now become infected with whatever virus it is. And he studied that in Varroa and bee interactions, how they passed the viruses, and also a Varroa feeding on an infected bee, could it get the same virus that another Varroa had infected that bee with? It's actually an important experiment because we all know that suddenly your bees can get sick with the PMS, paralytic mite syndrome, which people are talking more about recently. He said if you want to know if you're having cannibalization happening in your hive, he explained how you mark one cell with whiteout and then you can count. And he has a plan for, you let the queen lay on that frame, okay? Then you come back and you count to see how many are developing and how many don't develop. They don't cap over because they've been taken out by the nurse bees. So if you're wondering if you're getting cannibalization in your hive and what the rate is, this is one way to do it. Okay, now I'm back to fungi. Sorry, I jumped out of sequence there. The other interesting talk on fungi was by Dr. Jennifer Hahn, H-A-N. There's her picture in the corner of the slide. Now, these are the fungi that you see on National Geographic or little YouTube videos. And we're used to the idea that fungi can invade the bodies of animals even when they're still alive. What she's been working on is one that will invade the bodies of Varroa and not harm the bees. A Metarhizium species that drills through the Varroa exoskeleton. She found it in soil. She just went and looked at native soil fungi. That way you know that the bees have already been exposed to it. And she was looking at, could she get it to tolerate cold soil, right? Cold soil fungus to tolerate the greater heat of the hive and not lose its virulence. Sometimes when an organism changes in one way, it changes in another way. She goes through how she did this experimental method. She explains it. I mean, how she sets it up and she makes the selection process for a deadly strain, yet still viable at the increased temperature of the hive. And sometimes we don't really realize the hive in the center of the brood nest is basically very close to our body temperature. If we're 98.6 and brood is to be held at like 93 to 95 in the center, yeah, that's a big change from the soil, which often doesn't really get much above 55 around here, unless it's in direct sun. It spends a lot of the year in the 40s, not quite frozen or barely frozen, but often not quite frozen, down in the upper 30s, low 40s, at least in my area. So, and then she talks about how she finds she develops the right strain actually, selects and selects and selects and selects and selects. And then how she scales it up and is successfully propagating this fungus on brown rice with some ground chitin. Chitin is the crunchy, like when you step on a bug and it crunches, the exoskeleton. So you've probably seen chitin, that word before. And then how to get the contact with the bees and the mites. Maybe the bees can carry it to the mites. Then she talks about why this works. And she talks about dicer and microRNA, polyphenol oxidase, which is a molecule that's important in immune response, in melanization, which is a step in wound healing. And I've hidden my last part of that slide. Oh, and that this may actually, with something like oxalic acid vaporization treatments, work even better. The lower left picture That's 2 Varroa mites that have been dipped in the fungi and set down, and she did the film so you can watch Varroa mites getting killed and destroyed, but in an actual video. On the right is that's one of her petri dishes that she grew in the lab of the fungus, the Mycorrhizum. And here's kind of how she did it. And she kept doing it and selecting until she got, these are actually, I think, Varroa bodies plated out and then growing out. And the ones that were the best at eating through the exoskeleton of the Varroa, and then plating them, and then putting them back in the hive and selecting again and again. It was an interesting process. Combining it with oxalic acid, that's a possibility. The other thing that might be combined with oxalic acid jumps us into a talk that I thought was an illustration of how commercial beekeepers have different problems than hobbyists. Actually, commercial beekeepers down in California, with the elevated heat during the summer and the wildfire, low air quality, low amount of forage available, and they're raising queens, and once they've got them raised, they have to bank them until they're needed. Banking a queen is trying to keep her healthy and in as much contact with other bees as you can until you actually place her in a hive where you allow her to lay, but you're putting her in a caged position. She's going to lose some of her laying ability temporarily, hopefully, and then she's going to lose some of her ability to produce pheromones. While you're banking her, and you would bank her to pull her away from that excess heat, pull her away from the wildfires, and actually while you're at it, if you were to just cage your queen, take a queen out of any hive, you can induce broodlessness. Because the Varroa mite relies on reproducing only inside of capped brood, if you have no brood in the hive for a while, mite population has to die if they can't reproduce. Some of the mites will age out and never be able to lay eggs. Sounds good. And there's all these ways that we take advantage of broodlessness. When you install a package, which is pretty much a swarm, and a package is pretty much an artificial swarm in a lot of ways, or capture a swarm and you install it in your hive. If you deliberately make a split where you put all the brood in one of the not the parent or donor hive, but in the splits that you're making 2 splits for a parent or donor hive. And then sometimes people actually, and this is done a lot in Europe, and people are looking at doing it here, if you could just cage the queen and don't let her lay. Put her in, she's confined, she's in the hive, she can still interact through a wire mesh with workers and a retinue, but she can't actually lay eggs that get raised out. Then you can take away where the mites could reproduce, you can drop the population. Commercial beekeepers are also interested in using this storage to combat, like I said, excessively high temperatures, wildfires, and dearth times. They actually save on feed. And when you multiply it out by thousands, 10,000s, hundreds of thousands of hives, feed savings are not to be ignored. So, indoor storage, cold. Oh, and then they found that if they could take away the mites' chance to reproduce and then hit the mites that are remaining with oxalic acid, the oxalic acid would have a far greater effect, and you could use fewer chemicals, fewer treatments on the bees. Did it with the wrong way. Now, when people store inside, I talked about temperature, but they don't control just the temperature. They control the light, red lights only, if any, and also the gas exchange. CO2 kind of makes bees a little sleepy, keeping the CO2 level actually up a little. If you do it, if you put bees after the big almond pollination, commercial beekeepers bring their hives back, there's some advantages. They may not have other forage to put the bees on right away, but the bees have a lot of pollen right then and probably nectar stored too. So if they can put them into storage until forage becomes available or until they have time to split them. And that's where our packages and our nukes mostly come from, is from the early pollination contracts where the bees have been successful, built up pollen, built up some stores, and they have a lot of capped brood that's ready to emerge. And something has to happen or those hives will swarm. Now we worry about swarming about 1 or 2 hives or half dozen hives, but for beekeepers who only have so much labor it's available to do the splits or set up the packages and nukes to be shipped to the north, they want to stall that. And by putting bees, taking them off something like almonds and putting them directly into inner storage, they can stall the swarming. 12 days cuts it down. Cuts it down so that 45% of them swarm. Just a couple of days more, it drops to a third, and 18 days in indoor storage, it stops the swarming urge. Now, this isn't something we would think of doing, but when you're dealing with commercial quantities, it's a good idea. Here's the summer queen banking problem that I was mentioning. Got heat, drought, wildfires, and people aren't always buying in this area. Okay, you can raise queens. This is the best time to be raising, right? Splits and packages. Okay, here's the supply line, but the demand falls in the middle of summer. There are some beekeepers that do, but basically they explain in the other videos that you're going to have better success in requeening if you're doing it at a good flow time of the year, the hive's at its healthiest, maximum. So supply and demand don't meet. And what happens is if in this negative where the demand falls below the ones you've already raised and you've got banked, if you could put those queens into storage, then you could sell them later when people are starting to think about requeening for the winter. Now, Washington State University has been very interested in this whole banking thing, and this indoor banking they're doing it east of the mountains or other locations, but it's Washington State University's Agricultural Extension Bee Lab that's interested in this. But they're keeping indoor stored queens, hives, etc., at refrigeration temperatures, more like the 32 degrees, not 32 degrees, 4 degrees. Maybe not that low. 4 degrees Celsius is a little above, so maybe about 40 degrees. But the Canadians don't bother to drop it that far. But part of that might have to do with their CO2 levels, and they have been doing this for years. So this is the opposite from summer banking. This is winter banking. In Canada, getting those queens and having them ready to go in the spring without shipping them. And there are problems with shipping across the Canadian-US border. Last I knew, you weren't supposed to be having living bees going across, hives or queen. In Canada, they tend to get their queens and hives and such more from like New Zealand. It's one of their big suppliers. But here they're banking the queens for spring. Now, how are the queens faring with this? You have to do a lab analysis, logically. And Dave Tarpey is one of the leading lab analysis. His name is over here on the... I hope I haven't lost anyone. Brandon Hopkins is the man in charge of this experiment. And he's shipping some of the queens out to for lab analysis, out to David Tarpey. He's also going to put some of them in the field and see how they perform. You can bank a queen, but what if she can't get her pheromones back up and she can't get her egg-laying capacity back up? What if she's damaged or super ages or something? So you need to be checking for that sort of thing. And that's what they did. And I put this in because I thought it was really interesting. I've heard about these queen quality reports, and here is one from the lab that was set up way back east by Dave Tarpey, North Carolina University. Just I thought it was interesting to see what the report looked like. All right, I'm going to jump again here. Formic acid. Does formic acid treatment for Varroa kill your queens or not? This didn't really answer that question, but they did look at the brood die-off. And the conclusion of this, of Dr. Ramesh Sagili from Oregon State University, OSU, when I use it as Oregon State University, I know it could be Oklahoma State University, Ohio State University, but in this case, it's Oregon State University. If you use formic acid, it is effective. It kills mites. It also kills brood. And so he does, and they actually went in and counted to see what percentage of brood got killed. He has a lot of students and graduate students that do this sort of work. They don't think the queen gets killed directly, partly because she has all her retinue and all the hive is taking care of her. They didn't see evidence of that, but some people say yes. They think maybe that it isn't that the queen is killed directly by the formic acid, but if the bees are stressed and they don't take good care of her, they're not bringing that royal jelly over to feed her constantly so she can lay 1,000, 2,000 eggs a day, then maybe she gets stressed nutritionally. Maybe she's susceptible. Maybe she gets superseded. She can't function. They reject her. Maybe that's what happens. We're not sure. It's hard to see inside the hive. So Ramesh Sagili will try higher concentrations of, he was doing oxalic acid too. And nothing was conclusive on the oxalic acid. It came out like the control because he used a very low concentration only once. So he said he would look at oxalic acid in higher concentrations and repeat it. He talks about PMS, the paralytic mite syndrome. And this is where people say, I had a great colony going into the winter, and by December it was dead. They just all dropped dead. And it can be paralytic mite syndrome. We may never identify exactly which virus it is, but it appears to be viruses transmitted from virus to bee and bee, from Varroa to bee and bee to Varroa, and then bee to bee directly too. Once the viruses hit a certain percentage of the populations infected, they pass directly bee to bee, according to other presenters I've heard talk. And their immune system can't handle it because they've been dead on by the Varroa mites. There's so many variables. He's going to work on that, and he warns everyone to watch out for Varroa fatigue. He talks quite a bit about Varroa. I didn't want to report too much on his Varroa studies. Do the post-treatment monitoring. Varroa fatigue is when you're just so tired of talking about it, thinking about it, and treating for it. You don't want to do the post-treatment monitoring, but you need to. And that's a repeat, I'm sorry. It was larger type though. What he did say was interesting and tied in with Nick Naeger's talk about nutrition, and that bees need an external source of sterol. And you may not have caught, I don't know how many people have caught on to, sterols are a part, like a subunit of molecules, such as cholesterol, steroid hormones, which bees have steroid hormones too. Their biggest one is like their growth hormones. Ecdysone. I have to look at it when I'm saying it. Juvenile growth hormones. Now, external means they can't make it. We can manufacture cholesterol in our bodies. We do. And then we sometimes control diet so we don't bring more in, but we actually make cholesterol all the time. It's in our cell membranes. It's actually has a lot of very important functions in our bodies and in bee bodies. They need 24-methylene cholesterol, not just any cholesterol. That's the one they need. The best source of that particular form is pollen, not pollen sub. So it's nice if you can get some pollen in your pollen sub, but most pollen subs don't contain any. When you increase sterols in the bee's diet, and he does lovely diagrams of this, it increases the proteins in their head and abdominal sections. Why is that important? In the head, a large part of the bee's head is taken up with the hypopharyngeal glands. Remember feeding the brood? The very young brood has to be fed what is almost royal jelly. It's a jelly very, very similar. All larvae pretty much get it the first few days, except the queen larvae get it their entire lives. The mandibular glands. They also combine the secretions from the mandibular glands, from the pharyngeal glands, with secretions from the mandibular glands when they're making that worker jelly. So protein content up there, when they're doing lab research and lab analysis, the fact that increasing the sterols in the diet makes them better brood raisers, better nurse bees, is important. Mandibular glands also are, you may recognize that from the queen's mandibular glands, for example. So there's pheromones and other processes happening that the protein level of the mandibular glands would affect. The abdominal proteins, fat bodies. And we talk about the fat bodies of bees, and it's easier if in your mind you just put the word liver in every time you hear fat body. It functions in the fat bodies, look fatty, and yes, they store a lot of nutrients like the liver. The liver it's a storehouse for a lot of critical, like iron and such. And then it contains a lot of enzymes. It's a factory. You may have heard that the human liver cleans the blood, detoxifies, breaks down drugs, and any other toxin that comes into the body. So the fat bodies are extremely, extremely important. And when the bees, I'm going to go back up to the top sentence here now. I skipped it. The diatinous fat winter bees, that's the fat we're talking about. It's not really fat. If the fat bodies are well developed in the bees that are emerging, and Ramesh Sagili was guessing, he said in Oregon about September 15th to about October 15th. We need really good nutrition for the 21 days of development before that those bees were getting. So in August, late August, when we sometimes are in a dearth, we actually need to make sure that the bees are getting enough pollen and enough just diverse, good enough diet in general, that those fat bodies properly develop in the winter bees that may have to live 4, 5 months, maybe longer, depending on how our winters go. When you're trying to decide, are your bees getting enough sterols and protein and pollen, look for that, the well-fed, wet, beautifully white, glistening larvae. That's a good indicator. When your bees are doing dearth behaviors like running around collecting odd items like grape juice was the one he mentioned, it may be time to try to give them whatever you can, even if it is pollen stuff and it's not pollen, but help them out with their forage. Then all the crops are different, and he goes into an abundance, diversity, quality issues on pollen, and in pollination contracts on a monoculture, you're going to see some problems, and some crops are just really bad. And they did some of this the good old-fashioned way. Some of his research he did with the number of types of pollens and how different they were by looking at the color of the pollen pellet, just like we beekeepers do to see what our bees are visiting, trying to guess what's that bright orange one, what's the really creamy, faint hint of yellow pollen pellet that's coming in. But he actually did counting the pollen pellets and such. And this is the slide that I was thinking of. The connection between sterol, steroid hormones, and cholesterol. Sometimes people don't understand. We're talking about sterols. That's what we're talking about. And he quotes a paper here. The newly hatched larvae that lack dietary sterol usually die in the first or second instar molting as they exhaust the sterol that they received in the egg from the mother. And did she have a good supply? That could make a difference too. Those molting hormones, those are steroids, ecdysel and juvenile hormone, just like with people. The same, are growth regulating, developmental regulating, I think a number of them. are steroids. I'd have to stop and think as to how many are. So he's warning you, try to get some real pollen into your pollen supplements and really watch that fall. The bees that are emerging September 15th to October 15th. And it's really hard to get a date. And that's the best date that anyone's come up with. If they're emerging then, 21 days before, you needed to have really good pollen in your hive, a really good nutritional supply. Those were going to be your winter bees who are going to have the energy in the spring to raise the brood with the queen as she ramps up her laying that she provides them with. Then he goes into pollen traps. I thought that was interesting that he went through different types of pollen traps quickly, because some people are very interested in this more as a sales thing, but feeding it back to your bees is possible. Very difficult in a cold, damp climate. I would collect absolutely daily, freeze immediately, maybe in little separate baggies. And there's rules on don't do it too many days in a row, like every third day if you're going to do it to a hive. So you'd have to plan how to be able to let the bees in or out. And they don't like going through those holes. So you have to make it the only entrance. There's some tips on that if anyone wants to talk about it at the discussion later. I think we're getting close to the end here. Dr. Tim Lawrence. Oh, I put this slide. He put this slide in his set, but I don't know why. I'm pretty sure he did it. This is actually, people are starting to talk about snot brood. You've heard about spotty brood. You've heard maybe about, the different ways that brood looks wrong. When hives are heavily infested with Varroa and they're getting these different viruses, they're just overloading, people will describe it as snotty and snot brood. So I just thought I'd put a picture in. It doesn't look right. I mean, look at these ones. This doesn't look right up here. Is that their tail ends up instead of their heads or whatever? I don't know. And then this is just wrong. And it doesn't look, it's not white and glistening is all I can tell you. It's not right. None of these pictures are right. And so if you hear the term snot brood, that's what people are talking about. He talks about what makes a good pollinator and how it's affected. It's a wonderful talk. I just didn't have time to really go through it. One way he pointed out that we have a habitat for pollinators problem is he said, now it's a headline on the news when there's a beautiful wildflower seen bloom, like those slopes there in the pictures. Oh, that looks so gorgeous. He says now that makes the headlines. That's on the evening news. That used to be all the time when you drove around the car. And thinking about it, yes, when I was a kid, we drove past fields of wildflowers all the time. He goes on and he talks a lot about the number of habitat and forage and the number of crop types, how many acres we're talking about, how many pounds of pollen, and what amount of money are we talking about in the crop produced or not produced when we have our pollinators or don't have our pollinators working at maximum. And the resilience in an ecological system before it alters to a new state. He gets into a lot of talking about the bigger view of pollination. And then he says, if you want good bee nutrition, it's in an ecosystem. The forage should be there. It's not like feeding lab rats. Actually, I think the reference he makes to lab rats might be more about the people who are trying to study bee pollination and all kinds of bee behaviors, including bee nutrition, by putting bees in little cages inside. Yes, they are doing that. But if it's the only way you can study the intake and the output, whether they get sick or not and how long they live, does it change their lifespan? Okay, but the real nutrition is going to be found in an ecosystem. Talks about the pesticides and integrated pest management. And he's saying CCD, you're going to get back to Varroa. Varroa is the problem of everything. It's causing all this that we're seeing. And for an individual bee's immune system to crash, which means that the hive's immune system has crashed. I think I'm almost finished here. He talks about the interaction between different pollinators, and that if growers believe it, we can get them to plant more forage if they believe that they're actually getting more pollination effectiveness. They could spread the hives that they have to pay out farther apart. And it's complicated, but it's true. Honeybees sometimes specialize so much they don't. When a honeybee is going to forage, a single honeybee, she listens to the waggle dance, she goes out, she finds her tree and her branch, she comes back to the hive. They have tracked bees and watched them go back to exactly the same branch. The problem with that is they're not going between different plants when they do that. They are going between different flowers, but they're not naturally going between different plants. And when you have other pollinator species there, the pollen exchanges happen better. The foraging behavior patterns change. Honeybees can be a little too efficient for their own business. If you needed a pesticide ratings or information, I just put that in because it's so hard to find the right site when you need one, a good, reliable one. Blueberries are one of the special cases. We have large blueberry crops in Washington and in Oregon. Tim Lawrence, he's up here. Yeah, he's up here in Washington. But in both, bumblebees can be better at pollinating blueberries, but they can't go very far into a field. They don't naturally fly as far as a honeybee does, and there's a lot fewer bumblebees. But if you can have those bumblebees there, they make a difference, a definite difference. And all native pollinators would be helped out too if you were planting with the idea of keeping those native pollinators and that increased pollination rate advantage by planting native wildflowers around or maybe even through a field. They talk about hedgerows and hedgelands. I think I didn't have time to really go into that. It was really interesting. Here's Tim Hyatt's talk, and he talks in words about what's going up in front of the legislature for this legislative session. If you get a call, would you call your legislator? And that happened with the liability. WASBA sent out a bulk email, and anybody that could would just quick send an email message or even just anything. Alert your legislatures that you think it's important. This is a very complex initiative. I could never do what Tim Hyatt apparently did when he served on this Washington's Pollinator Health Task Force, because he had to talk to small scale and commercial beekeepers, the growers, the native pollinator advocates who really think maybe we shouldn't even have honey. Some of them think we shouldn't even have honeybees at all because they're not native. And the Noxious Weed Control Board, who's always trying to rip out our knotweed, which someday there's going to be a beekeepers protest down there by the riverside because we like our knotweed honey and there aren't many nectar sources. Okay, and the pesticide applicators, and he's trying to make them all happy and get them all to talk to each other. And I don't know if he actually led this, but he sounds like a fantastic man that he could ever get these people to sit at the same table and talk to each other. But he came up with 5 areas of recommendations on habitat and how to control pesticides, use them more efficiently, public outreach and education, how to make the native pollinators happy, and research that could be done. And one of the tricky parts was he had to balance finding funding that was already there, which it is. It's really odd how government works. This probably makes sense to people who work for school districts or whatever. Oh, there's a fund over here that will pay for that, but it won't pay for this other thing. Or making it cost effective for a grower, for example, to plant seed. Give them a tax write-off, give them cheap seed, give them seed they can easily find, that is easy to get it to sprout, to set up, pay them to convert cropland or to do any number of things. It was very complicated. He did a wonderful job explaining it. Okay, I sort of raced through that. It was disconnected, but I hope you saw that for you, there is something you want in here. Trust me, there's something you really, really want. And I'll put a PDF of this under files on the group discussion page.